Hello again. My name is Sudha Katgari, and I welcome you back to the third installment of my session, Troubleshooting Catalyst 9800 Wireless LAN Controllers. Now, in this session today, in this section chapter today, we will be covering the most important content for this session, which is troubleshooting. So let's go ahead and get started. So on the ISXE platforms, there is a lot of different terminology associated with tracing. Some of the different types of tracing that you will hear about is ISD logging, binary tracing, always-on traces, trace on failure, conditional and non-conditional debugging. All of this tracing is fundamentally based off one single infrastructure, which is called the binary tracing. Now, the concept of binary tracing is really very simple. The idea is that all the Linux processes that are running on the binary OS, each of them will write all of their trace logs all the time. They will do so in a binary format, which will further then be compressed and stored for efficiency in terms of storage space as well as in processing. There is user CLI provided that will translate those binary traces into a user-readable string format. So that's the essential construct around binary tracing. Now, all of the other tracing that is mentioned in this slide is based off of the binary traces. How it leverages the binary tracing to provide different levels of data is what the rest of tracing is all about. So first, the binary traces, when they're written, there is a certain severity level associated with them. So you have errors, you have critical, you have warning, so on and so forth. Similar to how we used to have with Syslogs, but it's not the same mapping. So 2 may be critical here, 2 may not be critical for iOS, but you do have similar definitions. So as you can see, critical, as the name suggests, is really critical issues that are going on with the system, errors, warnings. Notice is more notification, something you want to be aware of, and it is informative. Then there is the informational one, which is a little more detailed and debug than verbose. Verbose is what we call the level 11. So it is beyond what you really should need to be collecting at all, but there is that. Along with the different trace levels, the binary traces also have this flagging system wherein the developers, while writing the trace logs, may have identified certain logs as being very useful for them to debug the process. These could be library calls, this could be database calls, whatever it is. Then they would have gone ahead and flagged it as internal. So internal is not really a level; it's more of a flagged. More of a flag that provides a certain view into the traces that are collected. Internal provides those more detailed, it calls upon the more detailed trace log levels to show the data. Let's first take a look at syslogs. So syslogs typically on an IS used to be whatever all of the IS processors would write. That would typically, it would just be in the classic IS, the IS writing logs into the syslog that was seen with showlog. Now that binary tracing is leveraged, some of the legacy processes in IS still continue to write those IS syslogs. However, on the binary traces themselves, most of them are not written. Only the error level, and even then the critical errors that are significant in terms of showing the state of a problem, those are the ones that particularly get written into the IS logger. So show log as the first output is a very good tool to know what is the health of your system. Are there any critical errors that the system is seeing? You can, beyond doing show log, you can also collect the same from simply going to the GUI troubleshooting dashboard and clicking the button for logs, and it will show. As you can see, the legacy traffic such as TFTP errors are shown up because there is no binary tracing for them, but also some of the important messages such as the error that we talked about for config validation of tags and policies is printed here. Always on tracing. As the name suggests, this simply refers to the binary traces for all the binoise processes that always write all the time, hence the name, right? These always on traces can simply be collected by going under the radioactive trace tab. The naming convention is a little off. These are actually just always on traces, but it is listed in there. Now, the concept of an always-on trace is the same, right? Traces that are written all the time, the level at which they are written by default is up to notice. It is not at notice, it is up to notice. So errors, warnings, critical, all the way up to the notice level logs get written out by default without any user intervention, right? So there is no need for somebody to run a debug or enable a command or anything. What it helps to do is if there is basic misconfiguration, like AP not joining because of a regulatory domain mismatch. Those sort of things will get root caused right away because the system will be monitoring for it. In addition, for the more complex sort of issues, it will not necessarily help with the root cause, but it will at least help you narrow the scope of the issue to know, like, is the client having authentication issue or a DHCP issue. It will also help to establish some trends. By looking back with always on traces, you can identify if there are certain APs that are having a problem or if there are certain client MAC addresses or certain OUI that is being impacted. The box has a capability to store up to 48 hours of for every process, which you can look back up to 2 days worth of logs, but only at notice level. Now, here are some CLIs that are typically used with always on tracing. You can go in and look at a per process level trace uh, by doing the show logging process. Uh, you can also use the command to write it into a flash file system and then display it on console. There is the ability to export by simply writing the output to the FTP server system or copying the file from the boot flash into the FTP or TFTP for offline analysis. Now, typically, customers are not really very interested in looking at each process and the trace logs generated by it. I mean, it is not really as conducive to troubleshooting. What would be more of use is being able to look at a particular client or particular access point and be able to troubleshoot for that access point or for that client MAC address. What is cool about the 9800 is it is not relying on the end user to understand the architecture and to run the binary traces for each of the process and bring it all together. It doesn't expect that. What it is going to do is if you let it know the filtering condition that you are interested in it, there is a profile configuration provided. So instead of show logging process, you'll be doing show logging profile wireless, and you provide your condition that the system will go and collect all the logs, contextual logs for that MAC address. Remember I said contextual, not a regex match. That means the actual trace log may not include the client MAC address, and that's perfectly fine. But contextual data of where all the client MAC has traveled, what all processes it has touched, and at what time, all of those trace logs are collected, collated, and presented in a chronological order to the user. Now, you can choose to look back to these logs from a particular timestamp or for the last 10 minutes, or you can look as far back as since boot time. Since 17.x, the default time for always on traces to look back is 10 minutes. You can make it larger, of course. Now, here's what a successful client connection would look like on an always on trace. As you can see, it's about 18 to 20 lines for a .1x SSID. It keys in on all the important states that you need to know about as far as the client connection. It shows you the successful authentication. It tells you about the policies that are in use. It tells you the LTE authentication went through successfully, shows you the mobility transaction, the DHCP success, as well as putting the client in the run state. Now, in a successful case, that is all you need to know, that you just want to be able to look at the packet. In fact, most likely you will not be looking at trace logs if the client is successfully connecting. It is when a client actually fails that we provide more details in the trace logs. So here, as you see, the authentication failed. So we don't just say authentication failed or give up or conk out. We actually give you a reason for why the authentication failed. In this case, it was a credential failure. Similarly, there is some more examples around AP join, where it is either unsupported model or the certificate is not valid or so on. These are all printed directly. So in all these cases, you could simply root cause and resolve the issue just by looking at always on traces. Now, the quick way on the GUI to look at always on traces is to go to that radioactive trace widget I showed you earlier. Click the add button, put your condition, and then go ahead and just generate. You're not clicking any of the start stop buttons, but you're simply doing generate. Now, one thing to note here is if you're just looking to look at trace log for a given process, that is not something that is possible from the GUI at this time. You will have to use the CLI. But as long as it is for a particular condition, the collated logs will be available by just hitting the generate button. You can either download it onto your desktop, or you can click this notepad sort of button to view the logs right there on the screen. Now trace on failure. Imagine an actual scale deployment where you do have client connectivity issues going on. While the always on traces are great where you can go back and look for a particular given client, what if you did not have the client MAC address handy? If you simply wanted to know the general sort of failures that were happening, say, over the last 48 hours. Trace on failure is that entity that will allow you to get that simpler view. There's a set of predefined failure codes that the system tracks on its own. Every time that failure code is encountered, it will increment the statistic for that failure code in the show wireless stats trace on failure output. So just by running that output, you can see if there's a particular failure condition that is being encountered and is that counter incrementing. Now, once you know that a particular failure condition is incrementing, you can look at the summary output to sort of get a view into, to get a little more detail around what is failing, which particular AP is failing with that condition. So as you can see here, we see a AP manager failure reason for multiple access points at different timestamps. So that corresponds with the statistics. And the condition listed is generally regulatory domain mismatch or unsupported AP is showing up, right? The one that is highlighted is for the unsupported AP. So along with now knowing that there's a AP manager failure, you also get additional data that it was an unsupported AP. You will get the MAC address that was linked to that failure, and you'll also get the timestamp at which the failure occurred. Also note that there is a UUID printed. The purpose of a UUID, or what is the universal UUID, is essentially to provide that context around a particular condition. What do I mean by that? Remember when I said if you have a client MAC, it doesn't mean that the client MAC has to be present in each of the trace log line. It is not a regex match. There's an actual context that is tracked by making use of UUID for the given client. So no matter which process it goes through to in its control plane flow, the UUIDs will keep track of it and collate the logs for all of those processes. Now, you could further use the show logging profile wireless command to specifically go look at a given UUID or a given instance of failure to get more contextual data. As in not just knowing that a particular AP failed with unsupported AP at a particular timestamp, you can go in and look at the file as far as knowing what was the workflow at the time, which AP model it was that was failing, and get more details like which policy tags or RF tags, etc., were being applied to it. So depending on the failure, some details would actually be helpful. Now, we have all talked so far about what the system automatically generates without user intervention. But obviously, not all problem cases can be resolved by simply using the always on tracing. There is going to be situations where you're going to have to get more detailed or higher debug level sort of logs in order to troubleshoot. The way that is done is by making use of what is called radioactive tracing. Now, radioactive tracing, it simply builds on top of the existing conditional debugging, right? You have a particular condition, there's generally a MAC address or an IP address based on which you run it. It is very similar to the AOS debug client MAC command. Similarly, we have actually a debug wireless MAC command here. Now, the unlike the errors where or other products that where you're running a debug automatically made it prints logs onto the screen and that's about it. That is not how the 9800 operates. When you run debugs on a 9800, those logs are collected and stored on the system and then get to be retrieved and displayed. So one thing for you to understand here is when we looked at always on traces, we were only looking up to notice level logs. And remember how it only printed about 80 to 20 lines? That is what it would look for each client. However, when you enable radioactive tracing for the same client, the number of trace logs that get written go up quite a bit. So if it was 18 lines, it's about 180 lines just for the radioactive trace because now you're writing the debug level logs as well. There's also the internal flag. when we say radioactive, there is a tag flag associated with or a customer flag associated with it, which is why it is only limited to 180 lines from what we view. However, when you enable radioactive, basically you are telling the system to go all out and write every possible trace log that it has been programmed to write. So, in fact, there are a lot more trace log lines that are written, a lot more space consumption that happens. So, when you are looking for internal trace logs, you're actually going back and saying, not just give me the debug level logs that are customer facing, but also give me the debug level logs that are developer facing. So you will actually get a lot more data. So the reason for pointing all these details out is really understand that when you enable debugging, it is not one of those things that you can just enable debugging and expect no impact. If you enable debugging and let the radioactive tracing run for say 10 or 15 MAC addresses and let it continuously, you may end up in a situation where the logs keep getting overwritten too often and a real problem happening in the environment doesn't get captured properly. So it is very, very important that when you enable debugs, you always make sure they were disabled. Now, how would you enable the radioactive tracing? You can go ahead and enable the condition, hit the start, go through the debug platform condition start, reproduce your issue, then stop it, and then go ahead and collect the show commands and view them on console with more flash. Not terribly difficult, but still a little bit difficult, right? It's a 6-7 step procedure. How do we make it simple? There is an inbuilt tickle script on the 9800 that actually does some of these functions for you. In that macro, you simply have to provide the MAC address or the IP address of interest by using the debug wireless MAC or debug wireless IP command. And once you do, you can also specify how long it should run for. If you want to limit it to 10 minutes, you can do so. And you can provide the destination for the output file. So by default, the tickle script runs for 30 minutes, but you can choose to set a timer. You can also choose to stop the debugging, even though it is set for 30 minutes, you can stop it whenever you wanted by running the no form of the command. Now the destination can be an FTP server or it can be the local file, but we generally recommend to the write to the local flash simply because any sort of problem with the FTP server or for write access permissions or any packet drops would mean that you will simply lose your debugging data. So it's always better to write to the flash and then either view it or export it. Now from the GUI, it has been made much easier. All you will need to do is go back, click on add the MAC address like we did before, hit the start button, wait, and reproduce the issue. Once the issue is reproduced, once you're comfortable, go ahead and stop the tracing. And then you can hit the generate button. Now within the generate, there is options. If it was something that you reproduced in the last 5 minutes and you want to look for the last 10 minutes, 5 minutes, whatever, you can look there. If you uh, if it is some sort of an intermittent issue that happened sometime during the last few hours and you're not sure, then you can go back and look for the last few hours as well. Or you can look for all the logs since boot time. Also note how it says enable internal logs. Again, there is no additional enabling. All you're enabling it is to collect the logs that are flagged for developer review. One little catch here, this is only to do with AP debugging for client. It is just a MAC address that you have to provide, but just for the AP debugging, if you use the AP radio MAC as your filter or as your condition, it will provide all the relevant information as far as the discovery. It will provide all of the radio information, RRM, all of those processes radio MAC will suffice. However, the DTLS transaction, which is the actual join request response or the tunnel building, for the AP to come up, that happened by making use of AP IP address. So just using the radio MAC will not give you a full view. Therefore, we recommend that you use both the radio MAC and AP IP address simultaneously to get an end-to-end view of what is going on with an access point. So depending on your filter, you're going to get the data. Now, as I previously mentioned, right, if you have debugging enabled, it writes 180 lines, and in fact, it writes a lot more lines. 180 is all you get to view. So it is very important that when you're done with your debugging exercise, you go ahead and clean out the debugging conditions. Now, if imagine a scenario where you didn't have a particular condition, it was not a particular client or a particular access point, it was just something like channel change is not happening. Those sort of scenarios where you want to know how RRM is running, how RRM manager process is handling it. In all those scenarios, you don't have to do any conditional debugging, but you have the option to do the unconditional debugging. So to do that, the first thing you would do is actually verify what is the current trace level set for a given process, and then you can go ahead and enable the process to a debug level. Within a process, there are multiple submodules. If you do the set platform software trace, say RRM manager, chassis active R0 question mark, you will see a lot of submodules, but you don't have to necessarily try to figure them all out. By simply using an all modules debug option, you should be able to set all the modules to debug level. Then go ahead and reproduce the issue that you're looking into, and then collect the traces. Again, the traces typically get saved to boot flash, and they can be viewed there, or they can be exported. And once you're done, you need to reset the debugging back to the notice level or set it back to default. Now, as I mentioned before, you can either do it for a process, or within a given process, you can choose to do a submodule alone and increase its debugging level. In this case, we are giving an example where MDNS has been set to verbose level. MDNS is quite a chatty protocol, so a lot of the logs for MDNS are written at verbose level, just so we don't end up with a lot of always on traces. Remember the space utilization and how we have to be optimal about it. So to that end, MDNS logs are written at verbose level. So in this example, we are going to set MDNS within the WNCD for to verbose level and take a quick look. So when a service learning is done, you will see a successful MDNS advertisement being listed. There's also the example where the advertisement failed, where we dropped the MDNS packet because the SPI was missing. So you will have that level of detail. So to quickly summarize, there are 5 different types of tracing available. ISD log is a Syslog. Binary tracing is the infrastructure that is not that of which runs all of the other tracing. Always on traces are real-time collection of events that provide a look back. Conditional debugging is where you're actually debugging based on a given condition. Non-conditional is also debugging, but it is not based on a condition, but it is at a process level. What will you use when? If you're doing simple basic client AP data collection, you can simply do always on traces and that will be fine. Advanced debugging, you get into radioactive traces and maybe even get into internal view of the radioactive trace, assuming there is some Cisco team involved working with you. For the basic health monitoring of the system, show log or syslog should suffice. In addition to all these tracing capabilities, the 9800 also has an inbuilt packet capturing tool. So if you remember from AOS, typically that would require us to, when we talked about uplink captures, it was always the connected switch. We had to look at, identify what model it was, what kind of packet capturing tools it had, whereas now we don't have to do all that. The 9800 has an inbuilt packet capturing capability. It will give you the packets that are destined to the box, that are leaving from the box, also that are passing through the box. So all of that are viewed into it. Because it's a PCAP, you can simply export to Wireshark. From the web UI, it's very simple. You go to the widget, you define the name, you define the buffer size, which interface you want to sniff on, and so forth. Both the physical and VLAN interfaces can be viewed. That will end you up in a place like this, where you can click the start button, reproduce your issue, whatnot, go ahead, stop the PCAP, and then you can export it directly to your desktop. Now, if you will see here, there is a filter option. The only filter options that are available on the GUI are IPv4 and IPv6. So if you're doing specific IPv4 or TCP UDP sort of traffic, you should be able to do just from the GUI. But in the use scenario that you're looking to do more detailed troubleshooting or more filtered or granular view, say matching on an access list for a certain port, like you might be looking only for HTTP traffic, or you might be looking at a particular client MAC. Those sort of filtering options are not available in the GUI. For this, you will have to use the CLI. In fact, uh, until recent code, the only ability we had was to look at the outer or the encapsulated packet. So the capwap header is all we were able to filter on. But in the 17.x code, the inner MAC has been added as an entity, which means now if you know the client MAC, you can specify that and only sniff traffic that is source and destined from that client MAC. Also note that even though you run the collection of the PCAP from the CLI, the PCAP itself can get saved to boot flash, and you should still be able to go to the file manager and download your PCAP directly from the GUI. a granular view. This was a packet capture done filtered on that Apple MAC address 0B8AC1, and as you can see the full flow that the client is doing, but just for the client without having to view. In the 16.x codes, we would have to filter based on the API IP address, which means all the clients for that AP would send traffic and would be seen in the PCAP. Now it's a much more cleaner view. In addition to the tracing, which is control plane, and packet capturing, which is just data, which is a packet view, we also have a feature called data plane packet tracer. Now, the point of a data plane packet tracer is not to give you a PCAP, but it is more to give you a view of a specified traffic and see how the traffic is being processed through the POX as it passes through the data plane. Remember how we talked about data plane gets plumbed and gets programmed with all the features that apply to a client. So not only does it have a client entry, it has to know this client belongs to this SSID, therefore this ACL needs to get applied or this QS policy needs to get applied, so on and so forth. So there's a lot of features that need to be processed for each given frame. That's what the data plane is responsible for, and Packet Tracer gives us a view into that feature processing. The way you would enable it is simply using the same debug platform condition command, except there's no feature wireless, there's just the MAC address that you would specify. You started, you can check by using show platform conditions, and you can enable packet tracer as well as specify the number of packets by using a singular command, the debug platform packet tracer command, packet trace command. FIA trace stands for feature invocation array trace. Basically, that will allow you to see all the features that are getting processed for a frame. A quick way to verify if the packet tracer is working is by looking at the statistics of what packets are getting traced and collected. A summary output will give you a view of all the packets that were captured, but only in summary. It won't go into the packet. It will just tell you what type of packets were captured. So there's like a source destination, some basic description associated with it. Furthermore, you can take all of those packets and redirect the packet to a file and view it externally. So the details of each packet will be visible. What would a packet look like? For example, here is an example where a packet came in on VLAN 1104. We still don't know where it was meant to go, but it was a DTLS packet and decryption was one of the steps we were doing. So the decryption feature was applied. You will also see how much time it took to do the decryption. So the lapse time will help you understand any scenario where you see performance issues where the packet comes in, but it is taking a long time to leave the 9800. So this tool would very much help to understand in which feature is it getting taking a long time processing. Now, again, this would be the next feature where now it has identified this is a control packet after decryption, so it is issuing a punt for it. And then comes the point where it is actually punted to the Linux socket towards WNCD. So at each point, you will see the duration it spent processing a feature. So if you know those performance issues, this is a great tool to use. In addition to the packet tracer, there are a few other widgets and troubleshooting tools that are available to us. So let's take a closer look at the GUI dashboard. We talked about logs, we talked about packet capture, we talked about radioactive tracer. But we also have this thing called debug bundle. Now, on the 9800, there is no predefined debug bundle. This is actually a customization of all the outputs that you want to collect that you can zip together, especially when you have a tag case open, when you are required to collect 3, 4, 5 different things. This is a great way to put them all together and send it as a single file. So what you would do is this show run is implemented as an example, so you can delete that, and then you can collect say Showtech wireless. That's one of the most commonly requested outputs on a tag case. So you would type in Showtech wireless and click on add so that that particular output is collected and the output is added to the debug bundle. In addition, depending on what you're troubleshooting, if you're doing any web access issue troubleshooting, then you can do web server log, or if there's a crash, then you could link the core file, or if any radioactive traces were collected, you could link them here. All of these files can be put together and a bundle can be created and exported out. Showtech support wireless is probably the most commonly used in the wireless space, but there's also other feature-specific Showtechs that are available for use, like Showtech Wireless QoS or Showtech Memory or Showtech Wireless Multicast. So instead of collecting 10 different outputs, look for a Showtech output that might be beneficial to as a macro to collect multiple outputs. And if one doesn't exist, let us know. Now, there is also the other widget for core and system report. So every time a 9800 restarts, uh, because it hung, it crashed, whatever its reasons, it will write out something called as a system report. A system report is going to include a core file that includes all the tracebacks and stack trace of what was happening at the system. It will also include all of the trace logs up until that point. So that system report is generally plenty sufficient to root cause why a crash occurred. So the good thing is there is a download option in there, so you can just directly dump it onto your laptop or desktop that you're working on and upload it to a case. In addition, we also have the ping and trace for utility, which, as the name suggests, it's meant for pinging, identifying connectivity, or checking the trace route. We also have this AP packet capture widget. Essentially, what the AP packet capture is about is where you put the AP in a sniffer mode so it can collect over the air traces. If you do not have a MacBook or handy, if you have an AP that you can use. Now, this is a feature that is only available on the IS access points. On the Wave 2 access points, there's a different mechanism to get to the same end goal of collecting the over the air traces. It's just a different infrastructure and set up differently. The widget on the 9800 is only designed to work right now with what the ISAP infra is, not the other platforms. Um, I've listed a document on how you would leverage it. Now, in addition to all the troubleshooting UI, there are a couple of other tools within the 9800 that are quite helpful. One of them is the GUI-based CLI editor. So imagine a situation where you have set up some local username passwords, but you didn't have any AAA. Then you go ahead and start a .1x SSID. By default, when you do .1x or any of that configuration, you would have enabled AAA new model. What that ends up doing is it will disable the login local on the VDY session, and you have to put in AAA authentication login default local for you to be able to gain SSH access. Uh, on a typical, without this editor in place, you would have to console into the box, reboot, break in, and sort of recover from there. However, the GUI-based editor makes it really simple because HTTP access is not the same way as the VTY access or the terminal access. So you can go into the exec mode here and run some show commands, or you can go to the config mode and undo whatever misconfiguration you might have done, or add the AAA authentication login default local to regain SSH access. It has come quite a few times handy for me. In addition to all the tools that I described or capabilities that are on the box, we also have some tools built out by our developer community that is posted out on developer.cisco.com. These are cloud-based tools for config analysis, for collecting certain statistics or data from controller and access points together, as well as some telemetry tools. So explore them and make use of them. That's all I had in the troubleshooting section. Thank you very much. See you in the next chapter.